This video series covers the basics of working with our Central software suite. If you don't have Central up and running yet, you may want to check out our Getting Started video for more information. This tutorial will cover the hardware configuration module in Central. This module is one of the most used Central apps, as it lets you set the configuration for all inputs and outputs of our data processors. When you first open the hardware configuration app, you'll notice the nested file tree on the left. This file tree separates the inputs and outputs into groups for better organization. While the signal types and channel trees have the same content, I prefer the organization of the channel tree as it separates the inputs and outputs based on their location on the device. The front-end amp section contains an icon for each of our amplifier channels. You can adjust the appearance of these icons using the buttons in the upper left. I prefer this list view as it gives the most complete overview of the channels at a glance. A channel can be opened by either right-clicking and selecting Properties, or by double-clicking the channel. When the window opens, you can see that the Analog Input Properties window is divided into 3 columns, with some accessory options below. The leftmost column provides information on the channel as a whole, including an editable label, input ranges, and external gain. This external gain number should, generally, not be changed unless one is using non-Blackrock head stages. The other 2 columns in this window concern the data streams for the channel. Most channels are divided into 3 data streams: a raw data stream, a filtered continuous data stream, and the spike data stream. The 2 continuously sampled data streams are not enabled by default. The second column deals with both of the continuously sampled data streams. Let's start with the raw data. The raw data option is the channel sampled at the full sampling frequency, 30 kilosamples per second, without any software filters applied. Recording raw data is good practice, so that if you decide you want to filter differently or threshold differently in the future, you have the untouched data to go back to. To enable the raw data stream, simply check the raw data box. Continuous data can be enabled by simply selecting a sampling rate from the drop-down. Additionally, a filter can be applied in the exact same way. Finally, the third column deals with the spike data and is enabled by default. The default filter is a 250 Hz high pass, but this can be adjusted with the filter drop-down. In addition to filtering changes, one can set the threshold parameters for spike extraction. By default, it is a static -63 microvolts, but this can be adjusted using this field. Alternatively, one of our other thresholding options can be selected, such as auto-thresholding, which continuously adjusts the threshold during the recording based on signal energy, or the RMS threshold option, which sets the threshold equal to a selected multiplier of the RMS of the noise. The other sections in this window will be covered in future videos, so let's go ahead and move on to configuring the variety of inputs that are also available. The analog inputs are B and C connectors on the front of our processors, and, as you can see here, they have nearly identical properties as our amplifier inputs with a few exceptions. First, the analog input range is much wider, and AC input coupling and spike processing are disabled by default. Because this is nearly identical to the previous screen, let's go ahead and move on to the next set of inputs. Our other set of inputs are the digital inputs. The digital input bank has 16 bits, and if you are using the neural signal processor, a strobe bit that will capture the entire port at once. You can adjust the function of the digital input bank using this drop-down menu. This will allow you to select between strobe or non-strobe modes, as well as define the edge detection method. The NSP has additional options to split the function of the port near the bottom of this list. We will leave it in its default mode and move on. The next input, the serial input, is available on the NSP and is typically used to control the starting and stopping of recordings remotely, but it can also be used to log any serial data that you would like. Since its settings are minimally adjustable, let's go ahead and move on to our outputs. The audio outputs can be found on the bottom front panel of the NSP, and on the Seriplex Direct, they are the computer speakers. The left and right channel of the audio output can be adjusted independently, giving the 2 channels shown in this window. If we open this, we can see that the Audio Output Properties window has a drop-down function list. Typically, the audio output is used to monitor signal during a recording. If a monitoring option is chosen, you can select which electrode you would like to monitor using the channel selector. Alternatively, The Track Most Recently Selected option will cause the audio output to monitor the currently highlighted channel, which is a feature common between many central apps. The remainder of the outputs are only available in the neural signal processor. Analog outputs are a common way to interact with other devices. As we open it, we can see that the Analog Output Properties channels have an extremely similar window to the output properties that we just talked about, and can monitor signal in the same way. It also has the option to output a custom waveform that is built using a waveform constructor in this window, and can even be set to trigger based on given events within the data or other BlackRock applications, such as our video tracking software. This feature will be important in our future tutorial on closed-loop experiments with the BlackRock system. But for now, let's finish up with digital outputs. The final set of outputs are the digital outputs. The digital outputs have many of the same options as the analog outputs, but are digital, and can therefore only be high or low. The digital output has the option to monitor spike data, or output a continuous defined square wave. This tutorial covered the basics of the hardware configuration available in Central, and demonstrated the available options for each input and output from the data acquisition devices. For more information on input and output usage, check out our closed-loop tutorial, which will be posted soon. Thank you for joining us today for this tutorial, and be sure to check out our additional videos on the other Central modules. For additional information on any of our products, manuals can be found at www.blackrockmicro.com.